Hey guys, we're gonna learn about mass spectrometry. Spectrometry. How this works is you put your sample in here, and then an electron beam is going to go through the sample. Electrons are going to come off out of your sample, and now you're going to have a sample that's ionized or charged. And then it's going to go through this magnetic field, and in this part, this is where the particles are differentiated by their masses. So we know that isotopes have different masses because they have different number of neutrons. And so the more neutrons it will have, the heavier it will be. And so that's how we can differentiate different isotopes and how we know that they exist in nature. To read a graph, right here on the x-axis, we have the mass to charge ratio. That is also your AMU. And to read your y-axis, that will be your relative abundance. The number that you see up here on top of the bar graph, those are the AMU. Now, why do we care about this? Well, one reason is that it's very, very useful in archaeology, so we can know how old something is. For example, when a living organism is just living, breathing, it hasn't died, it is absorbing a lot of carbon-14. When that organism dies, it can no longer absorb carbon-14. It only has carbon-12 left in its body. So what's going to happen is that archaeologists are going to go in there and see the carbon-14 to carbon-12 ratio. And the more carbon-12 that is found in that, it means it's going to be very old. Another way that it's used is in forensics. Scientists can take samples of dried blood from a crime scene, and they can see what substances are in that sample of blood. For instance, they can see if there was any illicit drugs being used or involved. And my favorite application of this mass spectrometer is the use in the airports. One time I was at the airport and I was pulled aside, and all I'm thinking at this point is, oh my goodness, I accidentally smuggled a water bottle or something. But they were actually swabbing my hands for explosives. And so sometimes you'll get randomly selected, but that's what's going on there. And what they'll do is they'll put that swab, that sample, into a type of mass spectrometer, and they'll see if there are any traces of explosives. Let me know if you have any questions.